Hi guys. You should have already watched the Ed Puzzle video on kind of like a quick little introduction or a little refresher on exponent rules. Today, what I wanted to talk to you about moving on from that particular video is how do I use those rules in more complex expressions and how do I simplify them? So you also have today to work on this exponent practice activity. In the exponent practice activity 1 through 9, I think you have plenty of opportunities to be successful on that based on the information that was provided to you in that first ed puzzle. But I did want to go over number 10, a couple of examples from 10 to 18, because you're going to be using what you learned from that video to then simplify more complex expressions. So if you guys could please go ahead and move to question number 10. I'd like to do that one. I want to do an example where you're multiplying pretty complex terms together, one where you're dividing and then one where you're using that exponent to an exponent or a power to a power rule to simplify other terms. So we'll start with number 10. And in number 10, we have the expression 3xy squared times 5x squared y squared. Now you might be freaking out like, holy moly, what do I do with this? There's a lot of different things going on here. Well, what you're actually, it's a lot simpler than you might think it is. You're actually going to just be multiplying kind of like terms, like when you were combining like terms, when you were simplifying an expression that had x squared and 3x squared, or whatever it is that matched up. So in this case, we're going to do that exact same thing, but instead of adding, we're going to be multiplying. So the first thing I want to do is I want to identify each of the terms that are kind of similar, or the things that are within the term that are similar. So I've just highlighted the coefficients. Those match up. I can then look at my x parts of my term, and then I can then look at my y. Now, the way that you're going to combine this is just like using the exponent rule where you're multiplying where the base is the same. So I'm going to match up the ones that are like or have things in common. So for instance, we've got 3 times 5. That is, it has commonality because they're both whole numbers. The next one is x and x squared. Now we're able to move things around because the associative property with multiplication, it allows you to move things around without changing the value or anything like that. And then the last one, we have y squared and y to the 7th power. Now that we have them all matched up, then we're going to just use the regular rules of exponents when multiplying. So the first one pretty simply is 3 times 5. We have 15. The second part is x times x squared. What you're going to do is you're going to add the exponents. In this case, we have x to the 1st power plus x to the 2nd power, leaving us with x cubed. And then for the y's, we have x squared plus the 7th power, which would leave us with y to the 9th power. Don't freak out when you see something complex like this. You're going to be totally fine. All you have to do is follow those exponent rules, and then you end up with a pretty simple answer. I'd like to go over then number 13, the same way we did the other one. This is just like multiplication, except instead of the rules for multiplication where you add the exponents, you're going to subtract the exponents. So the first thing I want to do is kind of look at the things that are in common. I always like to use a highlighter to help me match things up and know what is it that I'm multiplying together, dividing together, or whatever. In this case, we have our constants, our x's, and our y's, and this is set up pretty nicely because they're right on top of each other, making it pretty simple. The first thing we're going to look at is the coefficients. 36 divided by -6. You're not going to do subtraction or anything. You're going to do regular division because this is just a regular number. So 36 divided by -6 is -6. Now we're going to move into the exponent rule of division, where if the base is the same, you just subtract the exponents. In this case, my base is x, and I'm subtracting 4 minus, if there's nothing there, it's a 1, leaving me with 3. And then in this case, this is where it's really important to make sure that we are just writing in positive exponent form. In this case, what I would do is y to the 9th minus 12, and that would leave me with a negative 3 for our exponent. I don't ever want to write a solution with a negative 3 in the answer. So since this is negative, the rule is that this is going to end up as the denominator, or you're flipping it around to the reciprocal. So we're going to rewrite this as the denominator. And since we've now put it in the denominator, we can make that exponent a positive. So whenever you see a negative exponent, you're going to flip it to the other side of the fraction. Now, if for whatever reason, and this is not the answer to this problem, but this would be an example, if you have 1 over y to the negative 3, that negative 3 is going to tell it to flip to the other side of the fraction, so you would just move it to the top. So that's something that you need to keep in mind when you're looking at negative exponents. We're going to do a little bit more practice in class, but I do want to make sure that you guys understand that if there is a negative exponent, it is going to flip to the other side of the fraction. The last example I want to go over is where we have a power of a power. So we have an exponent on the outside of all these other exponents. Just like you were doing in these more simpler problems, you're going to do the same thing where you're going to kind of distribute that exponent. So we have, if I distributed it, it would be 4 to the power of 3, a squared to the power of 3, and b to the 5th to the power of 3. And then you can just follow your exponent rules. So 4 to the power of 3 is 64. A squared to the power of 3, what you're doing is you're taking these exponents, you're multiplying, giving me a to the power of 6. And then for this last one, we're going to multiply the exponents. It's b to the power of 15, and that's as simplified as it can be. Now that I've given you a few different examples of how to simplify more complex problems with exponents, I'd like for you to go ahead and try to do the same thing on the rest of this activity with 11, 12, 14, 15, 17, and 18. If you have any questions, we're going to be going over more exponent rules in class tomorrow, so make sure that you write those questions down and you're ready to get going tomorrow. I'll see you tomorrow. If you have any questions, make sure you write them down.